Hello class. So in our last class we discussed ways of solving through a quadratic equation. However, we did not discuss how we can possibly graph it. So today we're actually going to graph the quadratic equation, and we're going to do it in a very simple way. So as you can see here, we have our quadratic formula put up right there as ax squared plus bx plus c. And what I've done is for a, b, and c, which can be any number whatsoever that you can think of, I put sliders on it that go from 10 to negative 10. What that means is that I can move this dial right here so that a is equal to, let's say, 7 or negative 3 or anything like that. So we can mess around with the graph a little bit. So what I'm going to do is we're going to look through each individual variable and see what it does to the graph. So let's start with a. So with a, first of all, what would you think would happen when we start moving a around? So when we start moving a around, we could see that the curve, when it's getting higher and higher and higher, the curve of the graph actually gets thinner, much thinner actually, and when we actually extend it back down to 0, it gets much thicker, a lot more space. Same thing happens in the negatives. Move it around, there's not much change. So let's move this there. And the reason why this happens is because of the fact that if we were to take the equation y equals ax squared, then we would always get that result because of the fact that with y equals ax squared, b is 0 and c is 0. So we would still get y equals ax squared. And from our lessons beforehand in parabolas, we can see that when a becomes larger, then it becomes much thinner. Okay, now let's move on to b. B is very interesting. So let's move the sliders. And you can see the line that we've created is moving around and kind of tilting. What do you think b is? Just from that reasoning. You can take some guesses. B is the slope. B is the slope of the graph. Because if we think about it again, let's say this is 0 and this is 0 as well. If that's the case, then y equals bx plus c. Does that remind you of anything? It's also the same as y equals mx plus b, our line equation. And m was the slope. So if we replace m with b, that means b is the slope as well. Now let's move on to c. And c should be quite obvious. It's the y-intercept. So you just move that around and you get the y-intercept. Now we can have some fun, play around with these numbers a little bit. So let's say I wanted to put these two under simulation. So I'm just going to press these buttons. Let's see what happens. So remember, it's going from 10 to negative 10 and continuously going around. Look at that. Now let's add in c. You can see it's bouncing from negative 10 to 10. Now let's add b. Kind of going a little crazy now, isn't it? Again, you can have some fun with this. So let's move all these sliders back to 0. Now let's actually solve a problem with this. With this one, a is 1. Let's say b is Let's say b is 5. Let's say c is 6. From our graph, we can tell by looking at this that our y-intercept is 6 from c right here. Our roots are negative 3 and negative 2, and you guys can do that with any formula you would like. And that our absolute minimum is at negative 2.5 and negative 0.25. Okay, and that's all the basics that you need.